Okay. So last time we discussed about set interface. So set will not allow the duplicates and it will allow the only unique elements, and different set classes we already discussed, like a hash set, linked hash set, and tree set. Tree set will follow the ascending order. By default order is the ascending order, and linked hash set will follow the insertion order. Okay. Hash set will follow the not it will not follow the insertion order. Okay. So these are the differences we learned from the last class. So today we will see queue interface. Okay, queue interface as well as map also. Map also we will see queue and map. So today we will complete the collections about the all the collections classes. So from the tomorrow onwards we will see about the uh, Java 8 features. Okay. So are you clear?
Yeah.
Okay. Yeah. So see, collections all are same kind of mannerism. It is a kind of when we are uh, when we are storing elements, right? So different classes, using different classes based on the different scenarios, we can uh, we can store these collections. But but we need to make sure we need to make sure the specific class and specific requirement. Okay, so that is the only we need to make sure. So let me explain this. Okay, queue interface. Okay, so now I'm coming to the queue interface. Okay, so in a collection, if you see here in the queue, dq is the double-ended queue. See, this is the priority key and this is the array dq. So priority key is the one of the queue implemented class, direct implemented class. And also we have a linked list also. So using queue we can implement the linked list. Why? Because see, linked list is extending from this queue. Okay. Okay, so implement from this queue. So we can use the linked list also, the queue behavior. Okay, and array dq is extended from the dq. So totally the queue interface is having here. So from this queue interface, this is the implemented class and this is the implemented class. So array dq also we have a queue interface as well as dq interface from the properties we are getting from here as well as here. So now you can see here, queue interface of the Java collections framework provides the functionality queue data structure. So you know, right, the queue kind of data structure when you are taking the tickets by standing a line. So who is the first standard that queue, right? That line, right? That man will come first. Why? Because he will come first. So he will get the ticket and he will come first. And the last who is standard in the last end of the queue, he will come at the last of the queue, which means the queue will follow order first in first out, first in first out. Are you clear? Hello.
Yes.
Okay, so it is extended from the collection interface. Of course, every list is extended by every collection interface is extended from the collection and iterable. So whatever the methods are available here, those all methods are available, all these interfaces. Okay, so classes implement using queue interface. Okay, so since the queue interface is a, we cannot provide the direct implementation of it. So this is an interface, right? So in order to use the functionalities of the queue, we need to use the classes that implemented the queue is array-dq, linked list, and priority queue. You can see here, queue implements the array-dq, linked list, and priority queue. So whenever you want to create an object for the queue, the queue of string animal one new linked list. Why? Because this is the implemented class. The same animal two array-dq. So if you want to implement this class, you can implement the same way priority queue, or you can directly take the instead of queue, you can directly take array-dq of string. Array-dq, you can directly create an object like that also, no issue. So now queue interface we cannot initiate directly, just uh, how we are giving, right? The same way here also I'm giving. So just I'm removing this linked list. Why? Because linked list is separate class, right? So I created directly queue implementation, linked list and priority queue. Array DQ I removed. Why? Because this array DQ D notates the double ended. Okay, double ended. So I will tell you what is double ended. So where I added yes. If you see here, if you see here, the queue data structure, right? So first of all, this is the starting point. Okay, front end. The first one stand here, the second element stand here, the third element stand here, fourth element stand here, fifth element stand here, sixth element stand here. So always addition will add here, rear end or last. Okay, rear end. So in the rear end, the elements are added. From the first end, elements are come out, which means deletion will be happens from the front end, and addition will be happens from the rear end. So this is the single bounded queue, which means normal priority queue and array list. Okay. So DQ also we have there classes implements from the DQ. Why? Because DQ also we saw here, right? You can see here DQ. So from here also we can implement some of the classes. What are those classes? We will see. Okay. First of all, see what are the methods are available in this queue. Okay. So in Java queue interface contains two methods, which means add and deletion. Okay, add and deletion. So you can use the elements to a queue. These methods are add method and the offer method. Add method and the offer method. What is offer method? We will see now. These two methods can add an element to the end of the queue. Okay, end of the queue. Just now we discussed it, right? So the front end we can delete the queue, and back end we can let me open that. See here we can delete the queue. We can add the queue. Okay. So here add and offer methods are different. How behaves if the queue is full. Okay. So both the methods, add method as well as offer method, are two methods we are using to add elements into the queue. Where? Here. Okay. So end of the queue we can add the element using add method as well as the offer method. Okay. So delete method or remove method, we will have to remove the element from the queue from the front end. We will see here. So if you see, so whenever the queue is full, how these two methods will behave, that is what we are seeing now here. So add method and offer methods different in how behaves in the queue is full. So no more elements can be added. No more elements can be added whenever the queue is full. Add method throws an exception in that case. So whenever the queue is full, add method will throws an exception. Whereas offer method just return the false. So it is what a simple difference between add and offer. If the queue is full, the offer method simply will throw the false, but the add method will throw the exception. Hey, queue is already full. There is no space. Something kind of exception will throw. So you can see, you can add the element one using add method. You can add the offer method also using element. So queue string of queue equals to linked list or priority queue. You can create any kind of queue here. So to take element from the queue, so how we can remove or how we can take the element from the queue? Poll method is there, remove method is there. Both the remove the elements from the queue. Okay. So you can use the poll or remove. Okay, you can. So, but why we need the two methods? So there is always reason. So you can check that difference here. Poll method returns null if the queue is empty. So whenever you are trying to remove element from the queue, if the queue does not have any elements, it will returns the null. Okay. The remove method throws an exception if the queue is empty. So that is what. So whenever you are trying to remove, element should be there, right? If it is not there, it will throw an exception. It will give the null pointer. So there is nothing is there to remove while using poll. So are you clear? Offer and poll and remove methods and add methods.
Yes.
Okay. So again, the poll method and the remove method both removes the first element in the queue. So whenever you are using a remove, right, it will take the first element. Okay. First element means here. So if you are using a pole, it will remove first one. If you are using a half remove pole method, it will use the next first element. Okay. If you remove here, this will be the first element, right? So like that it will be work, right? So you can see here pole. So first element will be deleted. So now again the queue is only one element is there. Again we are using remove method. From the remove method we can use we can remove this element 2 method. Element 2. Okay. So method description of the queue. So just now what I discussed, right? Offer and all, right? So just simply I added a description for each and every method. So element is also one method. This method is in the head of the and first element of the queue. Head element, the first element of the queue, it will return. Okay. So we know offer and remove and poll and peak. This is also one of the new method, peak. So this is almost the same as the element and peak. Okay, this is the add element will be written whenever you are using an element, and peak also same. It will return. The difference between peak and element is the peak method is returns null if the queue is empty. If it is yes, peak method will be returns null if the queue is empty. When you are trying to take the element from the queue, it's the same kind of removal operation, right? Like so, it is a read operation. So if the queue is empty, it will return the null. If the queue is empty, the element will return the null pointer exception or throw an exception. So the same kind of difference. So now we can see the example here. We can see the example. So let me copy this example and I will explain one by one. Okay. Okay. So we are taking the queue of a linked list. Okay. Or you can take the priority queue. Both are same. So you can see here. So we are adding a Rick, Maggie, Glenn, Negon, Doyle. Okay, Doriel. So these are the 5 names I added. Okay. So elements in the queue. So directly you can print the queue. Elements in the queue. And we can remove an element from the queue using remove method and would remove the first element from the queue. So obviously the deletion will be coming here. The first element will be here. It will go. Okay. So and head element, queue dot head element. So the if you see here, this throw the head of the queue, this is the first element of the queue. So it will take the first element. After using remove also, this will be the first element of next. Okay, it will take the element. So the poll, the method is removes the returns head of the queue if the returns if the queue is empty. So then again we are removing using poll element also, which means for example these two are removed. Now the head element will be the Glen. So Glen will be removed here. And the peak also element if the however it returns the null if the queue is empty. So we can also take this element here. So we are removing one by one. Now elements of the queue. We will see how the removal operation is happening with the read operation and remove operation. Okay, read operation is different and remove operation is different. We will see. Okay, so element and pole and peak, these all are read operations. This is the remove. So all these operations will be happens from the front end of the queue. Are you clear?
Yes.
Yes.
Okay, let me run. So you can see here, first of all, elements in the queue. So Rick, Maggie, Glenn, Negon, and Dariel. So removed from the element Rick. Why? Because we are using the remove operation. Remove operation here. Uh, remove operation. So when the Rick is not there, again the queue size is 4 elements. So now the head element. Whenever you are using the element, right? It is giving the Maggie. And also whenever you are using the pole, it is also giving the head element. Okay. Okay. If it is Q is empty, then only it will return the null. Okay. So again we are getting the Maggie. These two are the head elements. And the peak method works the same element method. However, it returns the null if the queue is empty. Peak method. So peak method it is giving the Glen. Glen. Okay. After add it is giving Glen. So that is also fine. Okay. And now you can see here. Now you can see here elements in the queue. Elements in the queue. So we can see here Glen. Okay. Peak method also it will remove. Okay. Peak method also it will remove. The peak method is works same as the element method. However, it returns the null if the queue is empty. The peak method. So it is taking the Glen. Okay, Glen only. So element add of the element in the first element of the queue. Okay, that's fine. So now we are getting the queue. The last elements here are the here 1, 2, 3, 4, 5. Remove operation is okay. So Rick is demand and head is the one element. First element is written the first element. First element. Okay. It is also written the first element. Poll method. So let me check that poll method. What is this poll method? This method almost same as the remove method. Yes. So poll method will be remove the element. So that is the reason we are getting here Glen. Peak is the head of first element. Okay. So that's fine. No issue. So now one example is done. So now we can go for the queue extend for the these are the interfaces. Okay. Now the interfaces we are showing. So interfaces extended from the another interfaces. Okay. So you can see here D notates the double-ended queue. Okay, double-ended. So here the D queue, sorry, blocking queue and blocking D queue. So these are the three interfaces. Okay. Now you can see working of a DQ data structure. So in general, queue element stored accessed in the first in first out. So it is the first in whenever we are adding that, right? First element will be first in, and whenever you are removing the taking the element from the queue, first out. So whenever you are adding the first element here, so first out, first element come here. So first in first out. These elements are added from the behind and removed from the front end. Element from the added from the behind, which means behind side. So right side and removed from the front side, removed from the front side or read from the front side. So Java queue interface, okay, represents the data structure designed to have elements inside and end of the queue and elements removed from the beginning of the queue. So just I defined one more definition. So now the class has implemented DQ. So array DQ and linked list, okay. These are the two classes are implemented from the DQ. So now working of a DQ. So in a regular queue, elements are added from the rear end and removed from the front end. However, a DQ it can insert and remove elements from the both the rear and front ends. Okay, you can add element here and you can delete here. You can add element here, you can delete here. So that is what a kind of nature. Okay, a kind of nature from the DQ. D means D notates the double-ended queue. Double-ended queue means you can add here, you can remove here, you can add here, you can remove here. Okay. So for that purpose, we have add first, add last, offer first, offer last, get first, get last, peak first, peak last, remove first, remove last, poll first, poll last. Okay. So like that we have methods. Okay. So are you clear?
Yes.
Okay. So
Yeah.
now we will see the one more double array DQ implementation. Okay. So these are the very very simple and it is very rare cases the queue will be used. Okay. So let me copy this. Copy this. After that we will go for the map. Okay. We will go for the map and we will see concurrent modification exception kind of things in map. Okay. So you can see here. So number of offers. Offer is also add right. So offer last, offer first. Okay. First of all, it is added one. Okay. So after 1 it is added 2. So before 1 it is added 3. Okay, 3 1 2. So this is the queue. We will see the numbers. And the peak first, which means it will remove the first element. Okay, and the peak last, it will remove the last element. Pole first, it will remove, it will read the first element. Pole last. Okay, we will see now. See here, queue, add offer last, offer first. Okay, offer first in the sense 3 is added first one, offer last 2 is added at the end of the queue, 2 is added at the end of the queue. So 1 is already added as normal in the front. Okay, the first element peak first, the first element it will take, the first element is the 3, the peak last, the second element is the last. Now pole first, pole is also one of remove the element from the DQ. Okay, so it is removed. Pole last, it is also removed. So you are removing using pole method, using 2 and 3. Why? Because those are the first and last elements. Now the queue elements, number of elements in the queue. Obviously it will be 1. Obviously it will be 1. So are you clear? Queue operations.
Yes, so it's clear.
Okay.
Yeah. Thank you.
Now, yeah. Now we will go to the, so remaining classes you need to do the practice. Okay, you need to create the array DQ. You need to create the you need to add all these methods from your practice. Okay, and also what are the classes I did not created here as part of queue. You need to create and you need to do the practice as a practice test. So now we are going to the collection. The next, the major part of the collection is map. So you can see here map hierarchy. Map hierarchy. Map hierarchy you can see here. So map, hash map, linked hash map, and tree map. These are the three classes. Sorted map is the interface. Okay. So map will always store key value pairs. Okay. It is not a single dimension. Okay. Array list and set are the single dimensions. They are storing the individual and objects as a sequential, but there is no key value pair. Okay. It is the key value pair. Map will always take the elements as a. There are two interfaces implement the map interface, map and sorted map, and three classes, hash map and linked hash map and tree map. The hierarchy given below. So this is what you can see, two interfaces and three classes. Okay, three classes from the map. So now one more behavior here. You can see in Java, elements of map are stored in a key value pair. Obviously, keys are unique. These are the unique. Why? Because if you want to store the values, it should be unique. Otherwise, it will be overridden by the the same value. So associated with the individual values, a map contains duplicate keys. Duplicate keys. You can have the same kind of value, and each key associated with the single value. Each key associated with the single value here. So why? Because it is only one block of code. You can refer a single key. Okay, single key associated with the single key value. Now map interface maintain the three different sets. Okay, set of keys, set of values, and set of key value association mapping. Whenever you are reading a map, right, you can get the all the keys, you can get the all the values, or you can get the elements from the map. Okay, so you see here, so these are the map classes we have: hash map, hash table, enm map, identity map, linked hash map, properties, and tree map, and weak hash map. Okay, so what are the those? We know only hash map and tree map, right? So we will see weak hash map and identity map. So how how those are behaving. Okay, so here is the some of the methods from the map, like a clear, contains key, contains value, equals, get, Entry set will give the set of values. Okay. Key set will give the keys from the map. So put method is nothing but add. Remove method is nothing but remove the element from the map. So size, hash map and linked hash map, tree map. So now you can see here class diagram of a map interface. Okay, so it is extending and implementing different classes, concurrent map and concurrent hash map, and tree map and hash table and hash map and tree map, after map and dictionary. Okay, so hash table and dictionary and properties are the Java 1.2. So those are the synchronized and not a thread shape. Okay, so hash table example. So let me copy this. Let me copy this. See here. So using put method, if it is a map using put method, you can add the key value pairs. Okay. So for each using for each also we can store. Why? Because these are the string comma integer. Okay, string comma integer. So whenever you are defining a map, you need to define the key values. Key what type of key you are storing and what type of value you are storing. You need to give that. Okay. So this is what generic. So a particular type of elements we are adding in a map. So generalized the elements, right? The same category, right? It is nothing but a generics. Okay, generics. So generic will always type notation. It will be strictly followed the type of variable or type notation. Okay. So now here we are adding elements. So for each string, right, key, right? So vehicles dot get key set. Key set will give the all the values. Okay, key value pairs. So now key comma vehicle dot get key. Vehicle dot get key. We will get the vehicle dot get key. We will get the value here. Okay. So the key here. So vehicle dot get key. So we will see. Okay. Now vehicle contains search key. So we Audi I'm passing this search key. If it is contains vehicle dot get search key. Search key we will get. Okay. So we are getting that value also. Vehicles dot clear. Clear means all elements will be removed. So again we will get the empty or zero size. Let me run this. See here. Total vehicles 4. This is the size of the first of all. The size we printed. So Audi 4. Audi 4. So the Audi is the key and the 4 is the value. So Ford 10. Here we are giving the Ford is the key and E is the value. So whenever we are adding, right, here, this is what we are getting. Okay. Okay. So found total vehicle search key and search key here. So found total 4 Audi cars. Okay, 4 Audi cars. Okay, Audi cars are the 4. Now after clear the operation size will be 0. So whenever you are clearing your collection object, so that will be size will be the 0. So are you clear? Map related operations.
Yep. Yeah.
Okay.
Yes.
So now you can see this is the output entry set. So this is also one of the let me take this while iterating map, right? So while iterating map, I will show you this. While iterating map, you can print like this. You can print sys out of map. You can print, or you can entry set, right? Entry set. Get set is different and entry set is different. So previously, here we are getting get key set. Key set we are getting. Key set means all the keys from the this map. But here we are getting entry set. Entry set means these are the entry set. So these three are the entry set. Okay. This is one entry. This is one entry in the map. This is one entry. So that is the reason they named it as entry set. Map dot entry is a one interface. Using this we can iterate the map. So it is giving the a map kind of reference here. So all the entry set will be loaded to this variable. So m dot get key. So get key and m dot get map get value, and inside this loop until the map size is correct. So you can see here key value pairs how we are reading from the map like this, or you can directly print from the map like this. So are you clear?
Yeah.
Yes.
Okay. So now tree map. So tree map also, and this is the linked hash map. So just now we saw that normal hash map. So linked hash map is also same kind of this. So you can print the numbers, which means directly print the these numbers 2 4. Okay. So linked hash map, using the linked hash map, even numbers that put 3. So third one also we put. Okay. Now you can print the numbers. One more is added. One more is added. Why? Because it is follow the insertion order wherever it is. Why? Because the parent of the linked list will be added here. Okay. So that is what. So hash map and entry set, key set and values also we can. So key set, it will give all the keys from the 1 2 3 keys. So 1 2 3 keys are coming. So numbers, just values, get the values, numbers of values, it will give the values. So these are the values 1 2 3. So you can see here in the map. Okay, like that we can add the methods. Okay, we can add the methods. Okay, and also you can see the entry set, key value pair. We will get the entry set, we will get the key value pairs, and directly we can print instead of iterating. While iterating, you need to go for the map dot entry of entry colon the set map values. Okay, so it will automatically convert the entry set. Okay, tree map example. So tree map also we have a different kind of it will follow the ascending order. Okay, ascending order. So ascending order of the keys. Okay, ascending order of the keys. So 2 4 6 1. Okay, one means not it is the first place, one means o, it is starting from the o. So it will take the key. So f is the first comes first, and o is the latter, and s is the latter, and t is the latter. Okay, so like that it is giving the ascending order. Okay, ascending order. And 4 6 2, the first one is the this one. Okay, so now tree map is done. So now you can see difference between tree map and hash map and linked hash map. So once we done the operations from the map, right? So we can see here differences. So hash map has a complexity of O of 1. Why? Because it is following the hash map internally. It is implemented the hashing mechanism. So that is the reason the retrieval operation is O of 1. So hash map allows the one null key and multiple null values. So values can be uh, but the key will be the always unique, right? If it is you are adding, try to add next one, it will automatically override it. Okay. So linked hash map. So it does not maintain the order. So order, right? So for order, you can go for the linked hash map. Linked hash map maintain the order which key value paired or inserted. So how you are inserting the values, the same kind of order will be preserved in a linked hash map. So this is also map, right? So O of 1 and linked hash map allows the one null key and multiple null values. So these two are the same from above, but here the third point is the little different. Okay, by identifying the linked hash map and hash map. Now tree map also O of log n. Why? Because tree map is extended from different maps, right? So you can see here. You can see here. See here, tree map. So it is implemented map and sorted map and navigable map. So that is the reason tree map will take more time when compared to hash map and okay, hash map. So here log of n, it will take the log of n. parenthesis into loop. Tree map does not allow the null key, but allow the multiple values. So null key it will not allow. Okay, null key means always key will be unique. Okay. Now this is what a map related information like hash map and linked hash map and tree map. So are you clear till now? So that we will go for the concurrent related concurrent modification exception related example.
Yes.
Okay. So this is the last operation from the map. So you can see here. You can see here. So this is the concurrent modification exception. So from the array list, so whether Java 1.5 it is coming, it is removing that exception by using the thread enabled classes. Okay. So concurrent modification exception example. Let me copy this. Let me copy this. Let me copy this. I will show you that exception. Iterator. So you're reading the values here. You're reading the values here. See here. So let me try to read the first elements without exception. So you're getting all the values from the list. Okay. So whether it is a list or map or both are same, I will show you the map also. So see whenever you're iterating the list or map, traversing the list, you should not add. You can add the values, but you should not do the any kind of removal operations. Why? Because see, reading is operation is good, but while doing a removal operation, so when the list is traversing, when the list is iterating, so such type of modification list is not allow you. So if you are doing like that, see, if you are doing like that, it will give the concurrent modification exception, which means dynamically you are doing some modifications here, which means you are directly removing the element from the list. So that will not allow. So you can see here application util concurrent modification exception. So it is not allowed the modification related things. So if you want to add, these kind of modifications, okay, you need to use the copy of array list. Okay, copy of array list. So let me use copy of array list. Okay, this is the list you need to use. Okay, so let me take this. Okay, okay, now you can remove the element here. So this will be the copy on write array list, which means you can remove and add, okay, elements from the array list. So whenever this is from the concurrent package, you can see here concurrent package. Okay, concurrent package. So let me run this. Now you are not getting any any exception here. So the same kind of values you can print after removing. After removing, see. Okay. The value you are taking here, right? Directly print the list here. List. Okay, that's fine. See here. So one of the third value will be removed here. Third value. So whenever the value will be 3, right? So we are removing that value. So once we are removing, the final list will be printed. So here, did you get any modification exception? Why? Because you are using this copyright array list, copy on write array list from the concurrent package. So whenever you are using concurrent package, so it will take that concurrent modification exception and all. It will be handled this package. Okay. So now you can see the same example on map also. Map also. Okay. Map also. See here. So this is the map. This is the map. So you can put here. You can put here. You can put here the values. Let me see. You are reading map value 1, value 2, value 3, and right. So you are getting the value by passing the key, right? So the same kind of. So if you, for example, if you try to remove here, concurrent modification exception here also you will get. You remove. You can give the key. Automatically value will be removed. Okay. When it is a thread enabled class. Okay. It is not a thread enabled. Okay. So you can see here. Concurrent modification exception. You are getting concurrent modification exception. If you want to do this, you can go for the concurrent hash map. Okay. So let me use the concurrent hash map. Okay. Yeah. Concurrent hash map. Now you will not get that exception. So you are able to print it. So are you clear?
Yes.
Yes.
Okay. So whenever we are using, right, whenever we are using this kind of doing this kind of operations, you make sure the values will be doing the operation should be doing a proper operations using the proper classes. Okay. Proper classes. Otherwise we will get exception. Okay. So from today's class we completed collections framework. Okay. So from tomorrow onwards we will discuss about the Java 8 and Java 8 features, and we will see how we can using Java 8 and what kind of problems we can do using Java 8. All we will see. Okay. Hello.
Okay. Yep.
Yes, I have a doubt.
Thank you, friends. Yeah, you can ask.
How can use that class in the threads?
Yeah, threads. That is what I am saying, right? See, this is nothing but a thread implemented. So internally it is implemented thread only. Concurrent in the sense thread enabled, which means it is synchronized. You don't need to use explicitly thread here. So which means one thread, iterator thread is reading the class, and another thread is you are removing, right? So these are the two kind of operations, right? So you should not see iteration is one thread. But remove is another thread, right? Whenever another thread is interrupting, right, it will give the exception whenever you are using hash map. Why? Because hash map is not synchronized, which means it is not thread enabled. So in that case, you can go for the concurrent modification, concurrent hash map to avoid that thread interrupted. Okay, sequentially it will do one by one, and also it will avoid the such kind of exceptions. Are you clear?
Yes, I got it. Thank you.
Yep. Thank you. So we will meet tomorrow so that we will start the Java 8 and Java 8 features. Okay.
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 Yep. Thank you.
Thank you.
Thank you.